Can your supply chain react fast enough when just-in-time becomes way too late? In just-in-time manufacturing, timing is everything. One delayed part can stall an entire production line. Real-time data turns your supply chain from reactive to predictive, helping you spot disruptions before they happen, so you can adapt instantly and keep production flowing without a hitch. In this video, see how IBM StreamSets turns delays into decisions, powering real-time pipelines that keep your supply chain resilient and production on track. Let's examine the power of real-time data for supply chain optimization by following the transformation of a fictional manufacturing company called XYZ Manufacturing. XYZ is based in Wellesley, Massachusetts, just west of Boston, and they have seen a decrease in their output from their assembly lines due to delays in their supply chain. The main causes of supply chain disruption are traffic delays and inclement weather. The factory uses local suppliers of raw materials needed for their just-in-time manufacturing operations, and they'd recently switched steel suppliers. They are now using a new steel company based in East Boston called Acme Suppliers. XYZ Manufacturing needs to improve their supply chain process to minimize costs because profitability has taken a real hit due to wasted materials and idle time on the assembly lines. There is some encouraging news from the supply chain, though. Acme Suppliers was selected as the new steel supplier, partly because they provide real-time data feeds from their trucks to clients. This real-time telemetry can be used by the data engineering team at XYZ to help predict when transport delays might impact the assembly line. Luckily, the data engineering team has IBM StreamSets to ingest and enrich the data before loading it into a customized real-time dashboard and alerting system. Let's follow along with the data engineer team as they build a real-time pipeline to use the telemetry data to optimize their supply chain. Within StreamSets, we'll create a pipeline and name it Truck Telemetry Ingestion and Enrichment, and click Next. Let's quickly verify we have the correct authoring engine, and we'll save and open in Canvas. Acme Suppliers telemetry data is published to an MQTT stream, so we'll add an MQTT subscriber origin. The admin team built us a connection already, so we'll select that. The topic filter is Logistics/Truck Telemetry. We'll move to the Data Format tab and select JSON from the Data Format drop-down list. The next step is to enrich this data stream with some other data we have in Single Store. The JDBC lookup processor stage lets us pull that data into our stream. We'll use our pre-built connector to Single Store, and we'll add a query to pull data related to weather and traffic. The query is using the location of the truck from the MQTT data and enriching it with some additional weather condition and route condition data that matches the geography of the truck's location. We're adding that enriched data to the pipeline. Next, we'll use the expression evaluator to add a new field that calculates the risk of the truck being delayed to the factory. This expression takes into account the distance remaining as well as the time remaining on the route. Here we are assuming a maximum speed of 60 miles per hour or a mile per minute, which is the speed limit on the local highway, and if the truck needs to drive faster than that to be on time, we are flagging it as a risk. Also, we are automatically flagging the weather condition of heavy snowstorm. All these conditions are hard-coded in this example, but we could use parameters to use different values each time we run the pipeline. The last step in our pipeline is to add the Elasticsearch destination. We'll use the pre-built connection and identify the index as truck_telemetry. And that is all we need to complete this pipeline. Let's validate our pipeline to make sure everything works. Everything looks good. Before we run the pipeline, let's quickly recap what we built. We're subscribing to an MQTT stream of truck telemetry data from our supplier. Then we are enriching the data with traffic and weather data. A new field is created that calculates the delay risk. And then we are putting this streaming data into Elasticsearch for visualization and alerting. Now, let's start the pipeline and start ingesting the real-time data from the trucks. After a few seconds, you can see the data moving through the pipeline. Let's move over to our Elasticsearch dashboard, and we can visually track the truck as it leaves Acme Suppliers in East Boston and heads west to our factory. Everything looks great until we approach the town of Newton. Here, the data points are turning red because they are being flagged as a delay risk due to either traffic or bad weather. This shipment of steel won't make it to Wellesley on time, Because we can see this potential delay before the truck delivery is actually late, we can make proactive decisions on how to best use our factory assembly line based on what materials are on site. Based on this real-time report, we won't be starting any jobs that require steel immediately. In just a few minutes, we used IBM StreamSets to create a real-time pipeline that optimized our supply chain. But wait, there's more. Did you know that IBM StreamSets has a robust SDK for Python? Everything you saw in the StreamSets platform can be duplicated in Python. Furthermore, the SDK can be used to programmatically build hundreds of pipelines quickly. Imagine this scenario if we had hundreds of trucks and hundreds of supply chain items to monitor. If you are interested in seeing the SDK in action, please click on the link below to watch the companion video for this scenario. Would you like to see how IBM StreamSets can take your manufacturing and logistics operations to the next level? Contact us for a live customized demo and a free trial of the software. Thank you for watching.